Hello everyone. In our last video, we talked about the introductory aspects of sequence and series. Here we are going to take few examples on arithmetic progression. The first question we are having here says, find the 13th term of the AP 5, 8, 11, 14, and so on. So, how do we find the 13th term of this AP? So AP means arithmetic progression shortly. Here is the solution. Here, the first term in this progression is 5. Hence, that is our T1. We have our T1 to be equal to 5. And it's still the same thing as our A. To know our common difference, we know the common difference is given by T2 minus T1 or T3 minus T2 or T4 minus T3, or in general terms we write Tn minus Tn minus 1. So here 8 is our second term and 5 is our first term. So we have our common difference, which is D, is equal to 8 minus 5, and that gives us 3. Now we are required to find the 13th term, and using the general formula for nth term of a sequence of an AP, which is Tn is equal to A plus n minus 1 all into brackets D. So now our 13th time will be T13 is equal to, our A is our 5 here, plus n minus 1, our n is 13 now, so we have 13 minus 1 here. Our D is 3. You have it as 3, and that will give us 5 plus 13 minus 1, that will give us 12, multiplied by 3. So we have our T13 to be equal to 5 plus 12 times 3, that will give us 36. And our answer will be 5 plus 36, that will be 41. So our 13th term, which is our T13, will be 41. So here we write our conclusion. Hence, the 13th term of the AP, which denotes arithmetic progression, 5, 8, 11, 14, and so on, is 41. That's it. Here's our second question. We are required to write the general formula for the nth term of the sequence 5, 11, 17, 23. So here's the solution. The first term of this sequence is 5. So that's our T1. The second term of the sequence is 11. So in order to get our common difference, which is D, we make use of T4 minus T3. And that will be T4 minus T3. That will be 23 minus 17, and that will give us 6. Here, I make use of our fourth and third term because some people might ask, is it only first time and second time we can use? No, we can use any of the term. Just make sure that you are using a term and its previous term. That is a term minus its previous term. For example, now you might decide to use T3 minus T2. It will still give you 6. You might decide to use T2 minus T1. It will still give you 6. So let's continue. We have our first term, which is 5, and we have our common difference, and we are to generate the general formula for this sequence. In order to do that, we know that the general formula for nth term of an AP is Tn is equal to A plus n minus 1 d. Now, for this same question, our Tn will be equal to, our A here is 5. And our D here is 6. So that's it. This is the general formula for the sequence. So Tn is equal to 5 plus n minus 1 all into bracket 6. That's our general formula for this sequence. Here's our third question. If the numbers 4, x, y, 14 number 1 over 2 form an AP, find the values of x and y. Let me take the question again. The third question says, if the numbers 4, s, y, 14 number 1 over 2, and so on, form an AP, find the values of x and y. So here's the solution. Our first term here is 4. That's our T1. And that's our A. Now, our fourth term is 14 whole number 1 over 2. And our first term is the same thing as our T4. And the formula for our T4 is A plus 3D. Now, that gives us 14 whole number 1 over 2. Now, what's our D? We know that to find our D, either we take the difference between the second term and first term, or the difference between the third term and second term, or the difference between the first term and third term. So here, I'm going to take the difference between the second term and the first term. So we have our D to be equal to, our second term here is x, and our first term is 4. So that will be, and it's still the same thing as T2 minus T1. That's what I use here. So I can call this equation 2. I call this equation 1. Now I want to put equation 2 in my equation 1. So I will have a plus 3d, sorry, our d now becomes x minus 4, and that will give us 14 whole number 1/2. So this is now the equation we are having. But recall that our a is 4, that's our T1. So we have 4 plus 3 into bracket x minus 4 is equal to 14 whole number 1/2. Now, when we open the brackets here, we have 4 plus 3 times x, that will give us 3x, minus 3 times minus 4, that will give us minus 12, is equal to, we can express this as a fraction, so we change it to proper fraction. We have 2 times 14, that will be 28, plus 1, that will be 29/2. Now, 4 minus 12, that will give us minus 8. So we have 3x minus 8 is equal to 29/2. So the equation we are having here is 3x minus 8 is equal to 29/2. In order to clear the fraction here, we multiply through by 2. So we have 2 multiplied by 3x minus 8 is equal to 2 multiplied by 29/2. The 2 here will cancel these 2. Yes. And we have 6x minus 16 is equal to 29. 2 times 3 will give us 6x, and 2 times 8 will give us 16. So here, the next thing we should do is collect the like terms. So we have 6x is equal to 29 plus 16. And we have 6x is equal to 45. So that our x will be equal to 45 divided by 6. Yes, there is something common to both numerator and denominator. So we can use 3 to divide this 6 2 times. We can use 3 to divide 45 15 times. So our x will be equal to 15/2, and that will be 7/1/2. That's the value of our x. Now, d is equal to x minus 4. So to get the value of our common difference, which is d, we have it as 7/1/2 minus 4, and that will give us 3/1/2. Now, to get the value of our y is our third term here, and that's our T3. And the general formula for our third term is a plus 2d. Now, we know what our a is, which is our 4 here, and we know what our d is, which is our 3/1/2. So it's easy for us to get the value of our third term, and that will be equal to, our A here is 4 plus 2 multiplied by our D is, I will prefer using 7 over 2 here. It's still the same thing as 3 whole number 1 over 2. So the 2 here cancel these 2, and we have 4 plus 7 left. And 4 plus 7 will give us 11. Hence, that's the value of our y. Thus, the values of x and y are 7 number 1 over 2 and 11 respectively.